Well, good afternoon, viewers. Today we have an '09 Chevy Silverado 1500, and it's here because it was running poorly. Check engine light is on, service airbag light is on, and the shop that was diagnosing it said they had no comm with the fuel pump driver module. And they apparently fixed some wires to the CAN bus on the fuel pump driver 6 months ago, but now this problem seems to have risen again, or is another issue. So we're going to go through a network scan on it and see what kind of codes it has to offer, maybe look at the network activity on 6 and 14, terminating resistance. Well, I'm having difficulty connecting to the ECM or PCM. Seems like we have a potential network problem here. I'm going to reboot the scan tool. So we'll try this again, automatic ID, see if it'll communicate. Now the vehicle was driven here and I just drove it in the shop. But I'm not sure what's going on with this scanner, if it's a scanner issue or if it's a vehicle issue. I just used the scanner a few minutes ago on a 2020 F-150 and it was working fine. Vehicle does not support automatic ID. Well, let's manually ID it. Fourth and fifth, Chevrolet Silverado, four-wheel drive. Okay. And I got to get the engine code, 8th character, the VIN. One, two, three, four, five, 6, 7, 8. It's a C as in Charlie. 4.8. Okay. Let's see if we got communication with other modules in the network. It's interesting that it runs. Communication with the airbag system, and it got a crash sensor 1 and crash sensor 2. It probably needs forward crash sensors. But no communication with the PCM. Normally it talks to the PCM first. HVAC, that's on the serial data. Instrument cluster, keyless entry. I'm pretty sure the airbag is on the serial data network. But where's the ABS, the fuel pump driver, and the engine control module? 6 controllers, there's got to be more than that. 7. TPMS. OnStar. I'm pretty sure OnStar's on the CAN bus. But we got no comm with the engine control. Surprising this thing runs. No comm with the engine control. No comm with the ABS, I would imagine. It's under 8600 with ES. Okay, let's check some network activity. So I got the breakout box installed to pin 6 and 14. The dual channel lab scope hooked up, and that looks pretty good. What I found when you start the vehicle, it goes quite wonky. Not very stable. You don't have to start it, all you have to do is turn the key to the run position. So we're going to measure terminating resistance across pin 6 and 14. I might have to wait for the battery to go. I'm going to have to disconnect the negative battery poster or just wait for the network activity to go to 0. So you can see the yellow trace is roughly 2.6 volts and the green trace is roughly 2.0 volts. Okay, it stopped communicating, but it's still a bias voltage of 1.9 volts, 1.85. Let's see if it goes to 0. So I calibrated the ohm meter and connected it across pins 6 and 14. Should read 60 and it reads 120, which means we have an open in the CAN bus somewhere. So let's get a network topology map and a wiring diagram of this thing to see where the problem is. I've had ABS modules do this, but that's interesting that the vehicle still starts and runs. So here's the OE wiring diagram of the high-speed bus from pin 6 and 14 at the DLC. It goes to the junction block and the IP just below the left side of the dash. And it goes to the OnStar module, which we had communication with. I thought that one was on that network. But we had no communication with the BCM, the automatic transmission. That's, no, we got, yeah, no automatic transmission, no engine control module. And it goes off to, on diesel applications, to the glow plug control module. That's interesting. Is that all there is to the high-speed CAN bus? Where's the fuel pump driver module? Is that on a different bus? So I thought an inspection would be wise. I see evidence of people being here. This connector is exposed. And then in the back here, you got the bonus Storman fuel pump driver module, but the original one is still connected, albeit not very well. I don't know what this connector is doing like that. Is that green corrosion? Or is that it? No, that's foil tape, I think. Well, we're going to go to the ABS module and disconnect it and see if the resistance changes. I suspect it'll still say 120 because it goes from the fuse panel down here, or not fuse panel, the IP junction box down here, through this to the module. Now I'm thinking that it's still got communication, otherwise it wouldn't run between the BCM and the PCM. The lock is missing off of this connector. Wow. The twisted pair right there, that tan wire. Focus. Those two tan wires are CAN bus wires. So I'm going to go upstairs and see what the resistance measurement is, and then I'm going to measure it from here to the back and here to the front. Get a pin out of this connector. So with the ABS module unplugged, it's still 122. So we'll get a pin out of the ABS module and check from there back. So I use an information source website called Comp9 to do a VIN search for the RPO codes that the vehicle is equipped with. Now they are on the glove box, but that means climbing up on the passenger side. So this is JF3, brake vacuum power, and JL4, control active brake control JL4. So this is the option code that we're looking for, because it's different for, there's 3 different variations of ABS modules on these trucks. So here is the electronic brake control module JL4 accept 10 series wiring schematic. Accept 10 series. JL4 accept 10. So in the diagram it shows pin 37 and 24. 37 and 36 are high-speed CAN, circuit 2500, and 24 is 2501, 23 and 24. So let's print this off. They're across from each other if I'm not mistaken. 24. Hmm. 38. I'll figure this out. So here's the connector view. 13 and 38 are the red wires. So that's at the bottom of the connector. 24 and 37 are coming from the front. And 23 and 36 are going to the rear. I've got the ohm meter connected between 24 and 37 and it reads 0.959 million ohms. I'm going to move to 23. Was I on the wrong pin? Not very good pin grip here. Okay, that one there. And that one there should be 120. There's no pin in here. It's like there's no pin grip. I'm gonna pop this plastic piece out of here. Well, this doesn't make sense. Pin 23 is definitely a CAN bus wire and it's been fixed. But pin 24 is not a tan wire, it's yellow. So maybe this is the wrong brake application. I gotta look for another pin out, but these pins don't match. Pin grip is crap on these things. You gotta be careful when you're probing these pins with probes and nothing more than 24 thousandths of an inch. But pin grip on this pin is non-existent. Non-existent. That one has got some grip. That one's good, but these pins are spread apart like if you're probing these pins with a probe, you got to be careful. Like this one here, you can see that there's good pin drag there. But this is a CAN bus pin here. And there's no pin drag whatsoever. When we're going to fix this wire, I should have some of these terminals from another brake module. This pin in here, that was 36. Yeah, this is 36. This is 37, and according to the wiring diagram, it's supposed to be a CAN bus wire, but it's not. But it's compromised too. And pin 24 has got some grip. 23, it's got some grip. So it looks like these two are going together. I gotta look up another wiring diagram because this is not right. So it's these 4 pins, but these 2 wires are yellow. One's yellow and that's 14 and 26. 26 is yellow and black, and 14 is yellow. I assumed they were both tan wires, but they're not. So we've got an open in these two here. Let's check across the other two. The pin grip is the shits on the existing pins, but this one here goes to the rear, I believe. That's open. And this one here goes to the front. And that's 132 ohms. So it's these two pins, 27 and 15, that goes to the rear. So it could be this one wire that's been repaired. I'm going to change it out right off the bat. That's this one here. I don't know what kind of hocus pocus is going on inside here, but these 4 pins down here, these 2 yellow pins and the 2 tan pins. The tan pins are 15 and 27, and they go to the rear. So there's some salvaged wires from another ABS connector that I changed out because it was melted. So there's the 2 tan wires, and there's the 2 yellow wires. So we're going to depin these and splice them. So there's the 4 wires replaced. I tried to reshape the terminals on these little guys here, but that's nearly freaking impossible. They're so tiny. I still have an open across the 2 tan wires, which is pin 15 and 27, which goes to the rear. So somewhere between here and the fuel pump driver module is an open. So we're going to go to the fuel pump driver now and disconnect it and short the 2 pins together, or the terminating resistor is open, because there's the terminating resistor up there. That's the terminating resistor up there. But this is pretty crappy looking here as well. So much grease on this thing, the magnet doesn't stick. That's highly suspicious, but that's not on the CAN bus wires. But we're going to look inside here and see what we see. So this is an absolute mess. There's one CAN bus wire here that's been spliced. These are the CAN bus wires here, the tan ones going in and out to the resistor. This has been repaired and spliced. Connector was packed full of dielectric grease. I've washed it out 3 times with brake cleaner. Again, you got to make sure you don't use probing pins that are too wide. So these 2 here, no grip whatsoever. That one's got a grip, but this one's got nothing. And that one's got nothing. Well, I'm gonna have to replace these pins in here too. I don't know if I got any more. Might have to cheat, use different color wires. I wonder if they're the same series as the connector from the ABS. Pry this lock out of here. Don't have any of these connectors. Imagine I could get one from the salvage yard. Well, that's easy. There's not very many wires in there considering the number of terminals that are possible. So these are the CAN bus wires up here, the tan ones. Or do we have an open in the harness somewhere else? No grip, no grip. Some grip. Oh, that's a gray wire, so that's not a CAN bus wire. So these are the other CAN bus, no grip. Look. So those 4 wires are compromised as well. But they've been repaired. One has been repaired. Is that all the problem? Why is this one backed out? Just the seal. Look at the seal rolled in there too as well. Sometimes I find that rust check oil tends to swell up these seals inside here. Oh well, let's see if these are the same series. Where's my release tool? I was using a little pin to release the wires. Maybe I better get a picture of this so I know which wires go into which terminal. Maybe jump these two together and see if I got a continuity. I get a pin out for this module. So I checked the 6 and 7 on the outside here, and that goes to the terminating resistor. That measured 120, and I've replaced all 4 wires in there, and I've got it shorted between the 2 pins coming into the CAN bus, and my ohm meter shows 0. So if I plug this in, theoretically I should read 120, I should read 60 ohms from, no, I should read 120 ohms because the terminating resistor is on the other side of that fuel pump control module. So let's plug this ABS module in. So I've got the ohm meter plugged in, I got the ABS module plugged in, I'm reading 136, which is a bit high, but it's definitely not open. So let's plug this ABS module back in, or this fuel pump driver module back in. Cleaned all the excess dielectric grease out of it. And see what we see up top. I had to change the seal inside there because it was swollen and I couldn't get the connector to latch correctly. But it's in there now. I still have to tape up this front harness and see if I can figure out a way to secure that connector on there, maybe with a tie wrap, because the lock is missing. But measures 61 ohms at the DLC now. So as you can see, measuring across 6 and 14 now at the DLC, we've got 61 ohms. The spec is 60 plus or minus 2 usually. So we're going to reconnect the battery and check the lab scope pattern and do a network scan again. So there's the CAN bus pattern now with the key off. There it's on. Notice the waviness to it. That's kind of normal for GMs, I've found, but not like it was before. It's nice and stable now. That slight wave to it seems to be normal. Let's do a network scan now and see what computers we can talk to. So let's got the key on, clean battery charger connected to it, set at 13.5 volts. See if it'll automatically ID now. Yeah, it does. Let's do a code scan now and see if we got communication with the modules that we didn't before. Yeah, engine, transmission, lost communication with BCM in the ABS. CAN bus communication symptom U2100, front end sensor. We got in the airbag, front end sensor 2, so it needs both front end sensors likely. We've got communication with the BCM now, fuel pump, HVAC, instrument panel, keyless entry, passenger presence system, radio. That should be close to the end of it. 11, 12, 13, 14 or 15 controllers. I think one of them is the OBD2 side of the ECM. So we got codes in the ABS, we got codes in the airbag that are unrelated, and lost communication with fuel pump control module. So let's do a network code clear. Clear all codes read by code scan. And then the only thing that's going to come back is going to be the airbag crash sensor codes. I managed to secure that connector on the ABS module with the 2 tie wraps. And I taped up the harness. So that's it for now. Looks like this one is going to be fixed. Let's do a post scan just for shits and giggles. Airbag codes are gone. Our anti-lock brake codes are gone. The front end sensors are still there, so he can deal with that. BCM. So the only codes after the network scan is the 2 airbag codes. This one will go away after it runs a self-test. Goes through a drive cycle. So we're good to go. Thanks for watching.